Hello, my name is Todd Schomburg. I work with Plinsky Agronomic Consulting as an associate consultant there and also a GIS specialist. Today I'd like to talk to you about how we use GIS and aerial imagery to verify micronutrient needs. The main talking points for my presentation are combining traditional tissue sampling or maybe a traditional other type of sampling procedure you use with GPS technologies. This will help you develop strategic scouting procedures, and I also want to show that in-field verification is very important. A little bit of background about one of our traditional scouting procedures, and that's in the past we've taken tissue samples to verify micronutrient needs. Traditionally we would take these tissue samples to verify micronutrients, and then we'd use soil samples to verify any sort of macronutrients needs, so pK, organic matter, pH. And we've been wanting to use air photos, so that was one of the things we wanted to get into, and we got hooked up with the OptiGrow program that John Deere used. And by using these air photos, we were able to use infrared and NDVI index to verify nitrogen needs, is what they were claiming that this would do. And what we wanted to do is also pair it with tissue samples to see if there's anything else that we could find out from these pictures. So our goals in all this was to pinpoint where to take tissue samples by using these air photos, and then we could compare the good and poor areas with tissue samples. So the methods in doing this was the air photo was taken just prior to tasseling. As I said, it used the infrared and NDVI index to determine stressed areas. They're claiming that the stress was due to nitrogen, and that's what we wanted to use the tissue samples to see kind of what was going on. So then these tissue samples were taken after we got the photos back, and this was about pollination time, and the tissue samples were taken using the ear leaf. It was done on about 2,000 corn acres and 50 fields, and traditionally it was a post-mortem test, so the results were applied to the following year. There was one rescue treatment where we just applied nitrogen because the cornfield needed it, but most of them were okay, and the in-field scouting helped prove that, and we used it for the following year to determine if we should add more nutrients or change up the fertility program. Most of these fields receive manure, and some receive commercial fertilizer. A little bit of background, as I said, our traditional tissue sampling technique was the W pattern throughout the field. So we would just walk in a W pattern, grabbing about 30 ear leaves as we went, and then this would be sent into the lab, and we'd use a field average. Now the new method is a little bit more strategic. So we got Bucky Badger with his GPS there, and what he's going to do is walk first to the poor area and then to the good area and grab two different samples, and then we're going to compare these good and bad areas. So this air photo in the background is using the NDVI index, and with that we were able to try to pinpoint areas to scout. And when you're walking pollinated corn, you know that it's really hard to tell whether you're in the best corn or worst corn. And even when I walked these fields and I got to that, in this case that first yellow spot, I wouldn't have guessed it was the poorer corn of the field. I would have thought it was okay. But with those, we were able to hear some of the results. So the infrared and NDVI could identify nutrient deficiencies in nitrogen, phosphorus, calcium, magnesium, sulfur, and manganese. And here's some real, basic results that kind of show that. And what this chart is trying to show is the percentage of deficiencies in the poor areas and the good areas. So when those tissue samples came back, we looked at the percentage of that were deficient, and the percentage in the good areas that were deficient. In this case, only 1% of the good areas were deficient in nitrogen, but 21% of the poor areas were deficient in nitrogen. Phosphorus, same situation, 1%, and then it jumped to 11% deficiencies in the poorer areas. Now potassium, it was pretty much equal, poor and good areas, and I'll touch on that a little bit more, and that's why I don't have potassium listed up here, because it seemed like that NDVI or infrared stress index really didn't tell us whether it was going to show up for potassium or not. They were all zeros for calcium, magnesium and sulfur in the good areas. So we had no areas. If we would have done our traditional sampling methods for micros, we would have had no areas showed up that needed calcium, magnesium, and sulfur. But in the poor areas, it was 1% of the time and then 2% of the time that needed calcium, magnesium, and sulfur. And then manganese, this one's a little bit similar to the potassium where it's a little both, but there was still 3% more of the time that we were able to show that the manganese stress was out there, and it wasn't showed in the good areas, and in the poor areas that stress was shown. Another results table, and this kind of shows that all nutrient averages were lower or the same in the poor areas except for potassium. So if we go through each nutrient, and these are just their percentages or parts per million, but what it's showing is in the good areas, here's the nutrient average, and in the poor areas, here's the nutrient average. As you can see, it's lower the same in all nutrients, except for in potassium. It actually was higher in the poor areas than in the lower areas. So what this is saying is that stress, the index that they're using really wasn't showing whether potassium was going to be good or bad. A lot of this seemed to, when I looked back at my notes, I think compaction was a bigger problem here than what is expected, is that even in some of these good areas there was compaction, and that was bringing down that potassium level, but the potassium level wasn't enough to bring down the plant to stress it, apparently. One thing I wanted to stress on was that field verification is very important, and like I got written here, air photos help scouting, and also scouting helps air photos. So some of my scouting notes are some red spots are low population. So it wasn't always that it was a nutrient, it was that possibly in comparison there wasn't as much leaf area out there because it was low population. Also, another comment I had a couple times was that smut and some rust was on the leaves. So what this showed is that rust was out there, or smut in that case, and a nutrient application would be, probably may help, but what the field really needed was a fungicide. And then two fields actually had this where these very green spots had no root worm, or excuse me, very green spots had no root worm lodging, yes, and the red spots were lodged areas. Or in this case, the root worm beetles were actually scalping the leaves. So you can see in this photo, the root worm pressure was so immense that in a few spots the beetles were scalping the leaves, so this brown area would show up on that air photo and then show it as being really poor corn. The corn wasn't the best, but again, a nitrogen application or some sort of micronutrient or nutrient wouldn't be the best thing. And I don't know, you can kind of see the beetles here on the leaves there and shadow of one there. So again, my main points are combining traditional tissue sampling or other sampling procedures that you may use today with GPS technologies. And by doing that, you can do some more strategic scouting and try to find those bad areas. And also that in-field verification is very important. So thank you for that time, and if we have any time, I'll field any questions.